Hi, good morning students. Previous class we done about the order of a reaction. Today is about molecularity. Okay, so what is molecularity? Molecularity means it is a number of species. It may be atoms, ions or molecules undergoing simultaneously undergoing collision to occur a reaction. Simply we can say it is a number of reactants or number of reacting species. Okay, so it is the number of reacting species. It may be atoms, ions or molecules. Okay, simultaneously collide to happen a reaction or to occur a reaction. Okay, we know when the reactants collide or react each other, then only we will get a product. So number of reactants or reacting species collide to get a product or to occur a reaction is known as what? Molecularity. For example, we can see here, this is the ammonium nitrate. This is the reactant here. Okay. Here how many reactants are there? One reactant. That reactants react or they will undergo collision to form the product nitrogen and water. Okay. So this reaction, if only based on the molecularity, the reactions are classified into unimolecular reactant, unimolecular reaction, then bimolecular reaction. Bimolecular means two will be there, two reacting species will be there. Then if three molecules will be the three reacting molecules or three reacting species is there, means it is known as termolecular reaction. Termolecular reaction. Okay. So simply we can say molecularity means the number of reacting species involved in a reaction. So for unimolecular reactions, example is this one. Okay, so ammonium nitrate, decomposition of ammonium nitrate, we will get nitrogen plus water. Here how many molecules of reacting species is there? Only one. That is why it is known as a unimolecular reaction. Second one, if you are taking here two molecules of hydrogen iodide, okay, then it is converted to hydrogen plus iodine. Then it is a bimolecular reaction. Why it is? Because two molecules are involved here. Then third one, here you can see 2NO plus oxygen. So total how many molecules are there? 3 molecules. That is why it is a which type of reaction? Termolecular reaction. Termolecular reaction means 3. And more than 3 or 4 undergoing collision at a time is not very easy, and it is less number of reactions are having, that is the molecular. Generally the molecularity with the 4 reactions are not there. Okay. Here, for example, I will tell you. Here you can see potassium chloride plus 6FeSO4 plus 3H2SO4 gives KCl plus 2Fe2SO4 thrice plus 3H2. No need of by hearting. Okay. So here you will expect how many number of molecules are undergoing collision or how many number of reacting species are here. 1 plus 6 plus 3. So total we will expect how much is the molecularity? 10. Right. Okay. But the molecularity of this reaction is not 10 and it is found to be 2. Okay. So how it will be means, this type of complex reactions, they will have elementary steps, simple elementary steps. Okay. So that sequence of simple elementary steps involved in a reaction is known as what? Mechanism of reaction, or it is a stepwise study of a reaction is known as mechanism, right? Okay. So the sequence of elementary steps, small single elementary steps involved in a reaction is known as what? Reaction mechanism. So they are telling for this type of reaction, we will expect it is 10 will be the molecularity and the order will be 10. But it is not 10, it is found to be 2. Why? Means this type of complex reaction involving the many steps or mechanism, it may containing many mechanism or many single steps or simple steps. Okay. In that, which step is the slowest step? Okay. For example, this reaction may be happen to 5 steps or 3 steps. In that step, which step is the slowest step? That step is considering as the is taken for calculating the rate of the reaction, and also the order of the reaction, and the species involved in that slowest step is considered as the molecularity of the reaction. Okay, so in this type of complex reactions, many elementary reactions will be there, elementary steps will be there. In that step, which one is the slowest step, that step will be considered for rate determining step, and for calculating the order of the reaction, and also for finding that species involved in that particular step is considered as the molecularity of a reaction. Okay, so for example, I will write one reaction here. The reaction is 4HBr plus oxygen gives 2Br2 plus 2H2O. Okay, so we will think how many molecules are there here. 4 plus 1, 5. So we will expect the molecularity will be how much it is, 5 we will expect, and the order also we will expect 5. Okay, order and molecularity, because it is 4 plus 1, 5. So the molecularity, we will expect the molecularity will be 5. But the actual molecularity and order of this reaction is found to be 2. Okay, so the molecularity and order of this reaction is found to be 2. That means this reaction containing, it is a complex reaction, and this reaction containing many elementary steps, or this reaction involve the mechanism. In that mechanism, which elementary step is having, which elementary step is the slowest step, that step will determine the rate of the reaction. That step will be used to calculate the rate of the reaction, and also the order of the reaction, and also the molecularity of the reaction. So how we will write this reaction is, it is having 3 steps. Okay, so HBr plus oxygen gives HOOBr, and it is the slow step. Okay, and the second step is HOOBr plus HBr gives 2HOBr, and this step is the fast step. And one more step is there, 2HOBr plus 2HBr gives 2Br2 plus water. This step also, which one, fast. Okay, so how we can write the overall reaction? So this reaction is containing how many steps are there? 1, 2, 3. Actually, this is the overall reaction. This step is this reaction is containing 3 elementary steps. Okay, so in these 3 elementary steps, which step is the slow step? It is given here. The first step is the slow step. Okay, and based on this, the molecularity, how many molecules are participating here? 1 plus 1, 2. So the order of the reaction and the molecularity of the reaction is found to be 2. Clear? Okay, so how we can write the overall? This we will get the overall reaction here. Okay, by cutting the values, we will get 4HBr. How we will get the 4HBr? 1, 2, 2 plus 2, 4 HBr plus 1 oxygen gives this HOBr. This HOBr will cut, and here also this one and this one will cut. Okay, then what is there? 4 HBr left side plus oxygen is there, and right side only 2Br2 plus H2O. Okay, that means this is a complex reaction and it is containing this many steps. In this step, which one is the slowest step? That step will be used for calculating the order, rate and molecularity of the reaction. So this reaction we are considering, and this reaction is having, what is the molecularity? It is the molecularity 1 plus 1 equal to 2 is the molecularity, and experimentally it is found that the order of the reaction is equal to 2. Okay, so any complex reaction is there means their molecularity they will containing many elementary steps. In that elementary steps, which step is the slowest step? That step we are considering for calculating molecularity, order, and which one, the rate of the reaction. Okay, so molecularity means what? It is a number of species involved, reacting species involved in a reaction. So Normally the reactions with the molecularity more than 4 is very difficult. Okay, so maximum we will get the molecularity 3. If more than 3 is there, means that reaction is a complex reaction and it may contain many elementary steps. In that steps, which step is the slowest step, based on that we will calculate the molecularity, order and rate of a reaction. Okay, so next is, this is about molecularity. Next is the difference between order and molecularity. Okay, I think in textbook 7 or 8 difference is there. In that only 3 maximum you have to learn. Okay, so I will write 4 or 3 or 4 5 here. Only maximum 3 you have to study. Okay, what is the difference between order and molecularity? All of you know order, then molecularity. Order means, last class it is the power, it is the sum of the exponents in a rate law expression. Remembering n equal to x plus y. Here x and y were the exponents. You are remembering a raised to x, b raised to y. Okay, that x plus y will give the which one, the exponents. Okay, so it is the concentration of a into concentration of b raised to y, it was there. So x plus y, so it is the sum of exponents in a rate law expression. But molecularity means what? It is the number of reacting species involved in a reaction. That is the molecularity. Then order may have which one? Fractional values. Order may have fractional values, but molecularity no fractional values. Okay, then order may have 0 values. Okay, but molecularity no 0 values. Okay, and order is calculated mainly based on which one? Experimentally calculated. It is an order is an experimentally calculated thing, but molecularity is which one? It is a theoretically calculating thing. Which one? Molecularity. Okay, and this order is mainly based on which one? Rate equation, right? Rate equation, rate law, it is order. But molecularity is mainly based on the mechanism of a reaction. Mechanism of a reaction. So 5, 6, 7 are there. Only maximum 3 or 4 you have to learn. Okay, so order means it is the sum of exponents. Okay, then molecularity means it is the number of reacting species involved. Then order may be fraction values, but molecularity there is no fraction values. Then order may have 0, but molecularity there is no 0 value for the molecularity. Then order is an experimentally determined thing, but molecularity is a theoretically based thing. Then order, it is based on which one? Rate law, rate expression, and molecularity is mainly based on which one? The mechanism of a reaction. So they will ask which one? Write any 3 difference between the order and molecularity. So clear about order and molecularity. Okay, so that is about which one? Order and molecularity of a reaction. Next is integrated rate equation. Okay, very important. It is a compulsory question, 3-mark question. Okay, so integrated rate equation. What is an integrated rate equation? It is a differential equation, gives the relationship between concentration of the reactants and instantaneous rate. Okay, so it is a differential equation which gives the relationship between concentration of the reactants and instantaneous rate. Instantaneous rate, the first class it was there, at particular instant what is the rate of the reaction, that is known as rate of reaction at a particular instant is known as instantaneous rate. Okay, definition is not required. Okay, so we know many first order, 0 order reaction, first order reaction, second order reaction, like that, third order reaction it is there. So they will ask, derive the integrated rate equation for a 0 order reaction, first order reaction. Okay, so listen here. First one is derivation of integrated rate equation for 0 order reaction. This only you have to learn. You have to derive the integrated equation for a 0 order reaction. So first listen properly here. We have to consider R is the reactant and P is which one? Product. Okay. So general reaction, R gives P. R is the reactant and P is the product. Now, for a zero order reaction, the rate is equal to, the rate depends on the zeroth power of reactants concentration. Okay. For a zero order reaction, the rate depends upon the zeroth power of reactants concentration. So for first order reaction, which will be, the rate will be depending upon the first power of the reacting concentration, concentration of the reactant. Here it is a zeroth power of the reactant concentration. Okay, so rate equal to K into, this is based on which one? Our differential equation. Okay, so rate equal to K into concentration, zeroth power of the reactants concentration. So rate equal to K into, K means what? Our rate constant in the concentration of R raised to 0, because it is a zero order. So rate equal to something raised to 0, this is equal to something raised to 0 equal to what? 1. Okay, so concentration of R raised to 0 will be equal to what? 1. So rate equal to K. Clear? Then we know the instantaneous rate, in the first class it was there, instantaneous rate equal to minus dR divided by D. D into concentration of R divided by dt. Okay, so instantaneous rate equal to minus D into concentration of R divided by dt. So just rearranging this equation we can write, because both are rate, so we can equate both. Okay, so minus dr by dt equal to K, because rate on the left side both are rate, so just equating we will get minus dr by dt equal to K. Okay, so dr, just rearranging, dr equal to minus K dt, just rearranging we will, D into concentration of R equal to minus K dt. Okay, after that we have to do the integration. So on integration, just you have to integrate this one. Minus D into concentration of R equal to, why I'm taking minus K out? Because it is a constant, we can't integrate. Okay, so minus K into integral of dt. We know integral of dx equal to what? X. Integral of dx equal to x, according to the integration law of integration, it is like that. Integral of dx equal to x. So here integral of d into concentration of R equal to what? R equal to minus K into integral of dt, means it will be t. Integral of dx equal to x, so integral of dt equal to t, plus I. I means what? Integration constant. I equal to integration constant. So we have to calculate the integration constant. So calculating the integration constant I, we are considering t equal to 0. At time t equal to 0, the concentration of R will be equal to R0. What is R0? It is the initial concentration. Initial concentration when t equal to 0. That means at that time the reaction is not started. When t equal to 0, concentration of R equal to R0, because it is initial concentration. Then substitute this value of which one? T equal to 0 and R equal to R0 in equation 1. This equation we will get what? R equal to R0 equal to minus K into T, we are substituting as 0, plus I. Okay, so we know this term will become equal to 0. Then we will get I equal to R0. Clear? I equal to, for calculating I, we are considering T equal to 0. That time the concentration of R will be equal to R0. That is initial concentration time. Reaction is not started. And substituting these values in this one. So concentration of R will become R0 and T equal to 0 plus I, we will get this value will become 0. So I equal to concentration of R0. Okay. Then substitute this Y value in which equation? Our equation 1. Okay. So R equal to minus KT into R0. I value we are substituting. So R equal to minus KT plus R0. Clear? Okay. So from the beginning R gives products. Okay. This one we will get until here. Concentration of R equal to minus KT plus R0. We have to arrange this equation. It is not the final equation. Okay. What we need, just arrange the equation. We will get we will get concentration of R0 minus concentration of R equal to what we will get Kp. Okay, concentration of R0 minus R equal to Kp. Okay, so how we will write the K? K equal to concentration of R0 minus R divided by K divided by T. Okay, so K equal to minus K equal to small k equal to, just rearranging this equation, R0 minus R equal to Kt. Okay, so K equal to R0 minus R divided by T. Okay, so this is the integrated rate equation for zero order reaction. So K equal to R0 minus R divided by T. Okay, so this is the integrated rate equation for which reaction? Zero order reaction. This is the integrated rate equation. So if they are asking derive the integrated rate equation for a zero order reaction, means you have to derive till here. Okay, then the graphical representation for a zero order reaction, how we can draw the graph. Okay, so consider this equation, that is R equal to minus Kt plus R0. This equation is in the form of y equal to mx plus c. Okay, this equation is in the form of y equal to mx plus c. We know y equal to mx plus c means what type of this one graph we will get. It will be a straight line, right? Okay, so we are drawing the concentration of R against which one? Time, and we will get a straight line, and the slope of this line, okay, we will get which one? Slope equal to, we will get minus k. Minus k means what? It is the rate constant, and this y-intercept, this is extrapolating this to y-axis, this y-intercept. Okay, this is the y-intercept. We will get which one? The value of R0. R0 means what? It is the initial concentration, because at the time t equal to 0, what is the R0? So the y-intercept, we will get the value of R0, and the slope we will get which one? Minus k. So what is the shape of zero order graph for the zero order reaction? For a zero order reaction, the graph is which one? A straight line. A straight line. Okay, so what is the, that is the integrated rate equation for a zero order reaction. What is the expression? K equal to R0 minus R divided by T. Okay, so we have to know some examples for which one? The zero order reaction. Examples for zero order reaction. 3 examples are given in your textbook, and the first example is which one? Decomposition of ammonia, NH3. We know ammonia means which one? NH3. Okay, decomposition of ammonia, 2NH3. I am not writing 2NH3 decomposition on hot surface of which one? Platinum. N2 plus 3H2 gives which one? 2NH3 ammonia. Then second equation is decomposition of HI. HI means what? Hydrogen iodide gives H2 plus I2. 2HI gives H2 plus I2 on which surface? Gold surface. Okay, gold surface. Okay, any 2 examples you can do. Some more examples are given in the textbook. Okay, so one is which one? Decomposition of ammonia, and the second one is which one? Decomposition of HI in presence of gold. Okay, then you can write this one also, formation of hydrogen chloride, HCl, that is hydrogen plus Cl2 gives which one? 2HCl, hydrogen chloride. That also you can write at the example. Any 1 or 2 is maximum enough for which one? Example for zero order reaction. Okay, so that is about which one? Integrated rate equation and example for the zero order reaction. Clear all of you? Next is T half. T half means it is half-life of a reaction. What is half-life of a reaction means? Simply we can say it is a time taken to reduce the concentration of the reactants to the half. Okay, at a particular instant. Okay, what is it? It is the time taken for a reaction to reduce the concentration of the reactant to half of the initial concentration, at a particular instant. Okay, so for example, how much time is taken to reduce the concentration of the reactant to half? Okay, so for example, in the beginning the concentration of a substance was 1 molar and it is converted to 0.05 molar, that is exactly half. Okay, within time of 100 seconds. So what is the T half? It is 100 seconds. Okay, so it was 1. To reduce that is to the half. Then what is happening? The time taken to reduce 1 to 0.05. It is a half. Okay, it was 100 seconds. So what is the half life for this reaction, or T half for this reaction? It is 100 seconds. Okay, so how much time is taken to reduce the concentration of the reactant to half? That is known as what? Half life. Okay, then next is, they will ask, derive the relationship between T half means half life, and zero order reaction, or show that the zero order reaction, the rate T half is directly proportional to which one? The initial concentration of the reactant. Okay, so what is the next question they can ask? Derive the relationship between T half and zero order reaction. T half for a zero order reaction. T half means half life for a zero order reaction. Or they will ask, show that the T half of a zero order reaction is directly proportional to the initial concentration of the reactant. Okay, so there is a question. One is that derive the relationship for T half for a zero order reaction, or show that the T half of a zero order reaction is directly proportional to the initial concentration R0. Okay, so listen here. We know this is while deriving that equation, we got concentration of R equal to minus KT plus R0. That first equation I derived here. Okay, so for calculating T half, when T equal to T half, we are taking T half, time as T half. Then R equal to, then initial concentration R, it was R, the beginning R, then that will become which one? R0 by 2. Okay, when time T equal to T half, the concentration of the reactant we have to consider as which one? R0 by 2. R0 by 2 means it is become initial concentration, it's become half. Okay, so when T equal to T half, R equal to R0 by 2. So substitute this one in equation 1. In place of R, we have to write which one? R0 by 2 equal to K into T. We have to write T half plus R0. Okay. So what? When T equal to T half, concentration of R equal to R0 by 2. Substitute these two things in this equation. We will get R0 by 2 equal to minus K T half plus R0. Clear? Okay. So just rearranging this equation, we will get what is that? KT half equal to R0 minus R0 by 2. Okay, just rearranging this equation, nothing is there. We are taking KT half to this side. So KT half equal to R0, or R0 is there, minus R0 by 2. Just rearranging. Okay, then KT half equal to, how we can solve this one? 2R0 minus R0 divided by 2. That is simple mathematics. Okay, 2R0 minus R0 by 2. Okay, so we know 2R0 minus R0 equal to how much it is? 1R0, right? So KT half equal to 2R0 minus R0 equal to 1R0. That is why R0 divided by 2. Okay, so T half equal to K into R0 by 2. Full rearranging. T half equal to K into R0 by 2. So that means we can write this is a constant, right? Okay, so can I write here T half is proportional to R0? T half is proportional to R0 because here K and 2 are which one? Constants. Okay, so usually to remove the proportionality sign we are using which one? Proportionality. To remove the proportionality sign we are using some constant, right? Okay, so I removed here this constant. In place of constants I am writing proportionality sign. Okay, so here we can see that T half is directly proportional to the R0. What is R0? Initial concentration of the reactant. So for a zero order reaction, T half or half life is directly proportional to the zero order of directly proportional to the initial concentration of the reactant. That is, T half is proportional to which one? The initial concentration of the reactant, R0. So this one they can ask, derive an expression for T half for a zero order reaction. Okay, so T half equal to K into R0 divided by 2. Okay, and they can ask, show that which one, the T half for a zero order reaction is directly proportional to the which one, initial concentration. So till here you can show T half is proportional to R0. That is, R0 is which one, the initial concentration. Okay, so clear all of you. That is about today's topic. Today we discussed about which one, the zero integrated rate equation for the zero order reaction, then which one, T half, half life, etc. Clear all of you. Thank you girls.